Hello everyone, in this video I am going to talk about climate change. This section is the fourth section of the unit 4 in the total unit of ecology, and this would be the last one. The essential idea is talking about concentrations of gases in the atmosphere, which is affecting climate experience at the Earth's surface. So there are some gases around the atmosphere, and these concentration of the gases will affect the temperature of the surface. Okay, I don't know why I have got two essential idea here. I don't know what happened to my slide. Anyway, all right. What is this greenhouse effect, which you have been heard about? This greenhouse effect, which you have heard about this greenhouse effect so many times in your life. Well, the easiest explanation for this greenhouse effect is that there are some gases, and there are the reasons that these gases trap the energy and get back the energy to the earth, and that's the simple way of explaining what is greenhouse effect. And there are so many articles and so many maps you can see, and the differences, like in the left, which is explaining from 1880 to 1889, and the right map showing 2000 to 2009. And there is a comparison between the temperature, which means that the temperature is increasing by showing the more brown color, and here is showing the temperature by like more blue color. This means that the temperature has been raised simply by showing the different colors between these two era and the increasing of the temperature. And of course there is a correlation between this increase of the temperature with the level of the carbon dioxide, which we are going to discuss about later. The understandings and things applications, so the things that you are going to learn is much more related to greenhouse effect and the gases and the carbon dioxide. You will learn about carbon dioxide and water vapor, which are most important and significant of greenhouse gases, but there are two more greenhouse gases, including methane and nitrogen oxide. So it's here. So methane and nitrogen oxide, there are other greenhouse gases. You will learn about how these greenhouse gases will affect or will impact on our temperature, the surface of the Earth's temperature, and that's by their ability to absorb long-wave radiation. So based on this ability, they can affect the temperature. And the warm Earth emits longer wave radiation as heat. Longer wave radiation is absorbed by greenhouse effect, and these greenhouse gases which keep the heat inside the atmosphere. Don't worry about if I'm explaining over this text. You will see from the image, and you will learn step by step very easily. And there is a correlation between the atmospheric concentration of the carbon dioxide with the global temperature. Both have the strong positive correlation. With the increase of the CO2, there was the increase of the temperature as well. Okay, a recent increase, I think it's the same thing that I mentioned, and threats to coral reefs from increasing concentration of dissolved carbon dioxide. These are something that you will learn. Once the carbon dioxide increased, then there will be a threat to the coral reef, because coral reef Okay, pause the video and see how much you know about this explanation. Can you say something? All right, I think maybe yes, maybe not, probably yes. The reason that coral reefs are in the threat by the increasing of the carbon dioxide, you will learn about that as well. Because carbon dioxide will dissolve in the water. We learned this before in the previous lesson, and make it acidic. And once it make it acidic, then it can damage the coral reef, because coral reefs are basic. With the increase of the acidity, they will get dissolved and they will get damaged, and they will lose, or they will be dissolved in the water by the level of the acidity. Correlation between global temperature and carbon dioxide, which I mentioned before, and evaluating claims that human activities are not causing climate change. Do you think it's right? Jesus, human activities are not causing climate change. Can you believe that? Okay, this is something that you will learn at the end. Yes. What is greenhouse effect? With a little more details. The Earth is kept much by gases in the atmosphere that retain heat, and these gases are referred to as greenhouse gases. So we will have something like as greenhouse gases, and these greenhouse gases will keep the heat. How is that possible? Yeah, so the greenhouse gases, they have the most and the largest warming effect. The most important greenhouse gases are carbon dioxide and water vapor. And also we have two more greenhouse gases as methane and nitrogen oxide. There is a video, and you will see the video showing a better animation than my explanation. So this means that once the radiation comes in, they are going back in their emission, or once they in the reflection, and in the reflection again they will be absorbed by these water vapor and carbon dioxide and these greenhouse gases, and they will be trapped. The energy will be trapped inside the Earth, on the surface of the Earth, and within the atmosphere. Nitrogen oxide are released naturally by bacteria in some habitats, and also by agriculture and vehicle exhaust. Greenhouse gases together make up less than 1% of the atmosphere. Okay, let's move. There are two questions related to greenhouse gases. Let's go back to answer this question after I explain from the image. One more. This is the video. You will see the video later. And again, this is greenhouse gases slide. Okay, I just jumped into this slide because I feel that if I explain the greenhouse gases from here, that would be easier to understand. So these are the steps, very simple steps from the greenhouse effect. The first of all, this is sun, and the energy from sun beats down on the earth. So the energy from the sun is coming to the earth, right? But what happens at this level, which is by number 2, some energy is reflected into space. So this is some energy which reflected into space, and the rest enter the atmosphere. The rest go to the atmosphere, right? So this is the energy coming from the sun. Some will be reflected from the atmosphere, and some goes down. And the earth absorbs the energy and emits heat, right? So here is the earth. Earth will absorb the energy, right? But also emits. This is the emission of the earth energy back, right? And once the earth will emit heat, then unlike other gases, greenhouse gases absorb and re-emit the heat energy. And this is the reason that we call them greenhouse gases, because they are absorbing energy, the greenhouse gases, imagine that they are here, they are absorbing energy and re-emit. And this re-emission will go to different directions, right? Some is emitted into the space and some back to Earth. So this emission from the greenhouse gases could go back to, go into the space or go back to the Earth in different directions. So either go to space or goes back to Earth. The heat is effectively trapped and warms the Earth. So because of that, the heat will here will be trapped and it warms the Earth. And I'm sure after you watch the different types of videos, you will see that there are explanations in every single video mentioning that, oh, if there was no greenhouse effect, then the temperature, average temperature of our Earth was 1918, which is completely crazy. Ooh, it is too cold. We couldn't survive in this average. You know, imagine that it's the average, right? So average is minus 18, not possible. The average of moon. Do you know what is the average of moon temperature? Yeah, the average of moon minus 18. Jesus, like freezer. This temperature is we were using this temperature for our molecular biology lab. Yeah, but anyway, we don't want to go to the moon and see this minus 80 average temperature. Anyway, all right, let's answer the question. Why is the surface of the Earth warmer at night if there is cloud cover? Pause the video. Okay, what do you think? Because the water droplets in clouds retain heat during the day and night, there will be radiation, the heat back to the surface. So during the night, this cloud cover, they are retaining the heat energy during the day, and during the night they will re-emit the radiation. So that's why when there is a cloud cover, night will be warmer, okay, because of the re-emission of the energy by the clouds. Next question, why is the surface of the Earth cooler when there is more cloud coverage? So you have to look at these two questions with the different views. One is looking at there is a between day and night that you compare getting warmer at night comparing to the day. But another question is comparing when there is more cloud coverage. So here the variable is different. If we have more clouds or less clouds, and if we have more clouds, then there will be cooler. The surface of the Earth will be cooler. Why? Pause the video. Yeah, that's the reason. The water droplets in clouds reflect a range of different wavelengths of radiation in both directions. So the more cloud coverage, the more different direction of the radiation. So that's the reason it makes it cooler. It doesn't allow completely the absorption of the energy. So yeah, and in both directions, including radiation coming inward that would have been re-emitted as heat. So when there is more cloud, means there is a more possibility that this re-emission, okay, when there is a less cloud, and this re-emission would be less. So that's why these different directions of the re-emission will kind of causing less heat. This is a video you will watch by yourself later. The impact of a greenhouse gas, you can see like as a flow chart. Ability to absorb long-wave radiation. The greenhouse gases, the reason that they're greenhouse gases are greenhouse gases and they can do what they are doing right now is because they have the ability to absorb the long-wave radiation. and also they are the abundance of them in the atmosphere. That's also important. The rate of the release and the persistence. So some of the greenhouse gases, the energy that they are releasing or they are absorbing, they are different, they are not the same. And the persistence means the time and the persistency that they are in the atmosphere. For example, water vapor and carbon dioxide are more in the atmosphere, but the carbon dioxide is more persistent. Here is the explanation. For example, carbon dioxide is very abundant, making up like 400 ppm by volume of atmosphere, like 0.04% carbon dioxide. So this is the abundance. It's 2 carbon dioxide in the atmosphere. About the rate of release and persistence, water vapor enters the atmosphere very rapidly, but only remains for days. However, carbon dioxide persists of years. So the rate of release, water vapor release very fast, but it's not as persistent as carbon dioxide. So these are the factors that affecting the characteristics or the effect of the greenhouse based on the type of the greenhouse gases. And the other one, which I explained, the ability to absorb long-wave radiation. Methane has 33 times more the effect of carbon dioxide, but is not as abundant. Okay, this is also important. Methane has more ability, 33 times more ability for absorbing the radiation. But the good thing or bad thing, I don't know if it's good or bad, but it's less abundant than carbon dioxide. This is very important when you are discussing about methane. This means that even the very short amount of the methane goes to the atmosphere, it has 33 times more effect than if it was carbon dioxide goes to atmosphere. That's the point. This is just I explained. Here is another explanation related to this greenhouse effect with the same, not the same slide, but with a different view. Approximately 25% of the solar radiation absorbed. This is how it's going. 20% of the solar radiation is absorbed by the atmosphere, and 70% of radiation penetrates. So what it penetrates is including like 75%. 75% is going down the atmosphere, 25% will be absorbed or not coming or inside the atmosphere. And from this 70%, they are including wavelength, different wavelengths. So I'm sure you know what the wavelength means, but it's very clear, nicely drawn over here, that these are the short wavelengths radiation. This is the middle one, and this is the long wavelengths. The long wavelengths color is red, so it's very beautifully has been drawn, this graph, and short wavelengths like purple and blue. From this different wavelengths, you can see the surface of the Earth absorbs short wave of the solar energy. So these short wave will be absorbed by the solar energy by the Earth, but it will be re-emission at the longer wave. So the longer waves will be re-emitted and as a form of heat. And these greenhouses are here. Hello, these greenhouses are here. Beautiful. So these greenhouses here, they will absorb the energy and they will re-emit the energy, and that's the reason the heat will be trapped because of the presence of the greenhouse gases. Up to 85% of the re-emitted heat is captured by greenhouse gases in the atmosphere, and this re-emission will be captured by greenhouse gases, and again the heat will be trapped. The radiation of the low energy infrared heat, right? Heat passes back to the surface of the Earth, causing warming. So I can say that the greenhouse effect originally is a good thing, right? If it wasn't greenhouse effect, then we had the average of minus 18 degrees. Jesus, we couldn't live anymore. Yeah, that's right. That's what I just mentioned, minus 18, if there wasn't any greenhouse effect. Here we go. There are videos over here. You will get these videos as well in your manage bag. And the other links that you can click on the PowerPoint slide once you have it and watch these links as well. Yeah, that's right. This is the end of the first video related to ecology, Unit 4 ecology, and the last section, climate change. Thanks for watching.